In this video, we're going to look at an example of a harder simultaneous equation. So let's consider these two equations. So we've got 12x squared minus 4xy plus 11y squared equals 64. So let's call that equation 1. And the second equation is 16x squared minus 9xy plus 11y squared equals 78. There's two parts of this question. Part A, by letting y equals kx, show that 7k squared plus 12k minus 4 equals 0. So I've got the solution here, so we're going to go through this one step at a time. Now, in order to be able to solve this, I guess, one of the clues is that we need to sort of eliminate this constant term. On the left-hand side, it looks quadratic, doesn't it? Okay, you think, okay, it sort of resembles a quadratic equation. We need to have everything on the left-hand side and nothing on the right-hand side. That was 0, in other words. So what I thought was, let's try something here. If I could find the lowest common multiple of 64 and 78, and your calculator can actually work that out for you. You don't have to do that manually, in fact. So to eliminate the constant term, let's find the LCM, so lowest common multiple of 64 and 78. So they're our two constant terms. And it turns out to be 2,496. In fact, if you just want to know how to do that on your calculator, I'll just quickly show you. Turn the calculator on, it's always a good first start. Press the alpha key, okay, and you can see there in red where it says LCM, so just there at the bottom, LCM. So push that and type in the two constant terms, so 64, 78, and we get 2,496. Okay, so that's that. So what we're going to do is we're going to multiply the first equation by 39 and the second equation by 32. Okay, so how do I sort of work that out? Well, 2,496 divided by 64 will give you 39. 2,496 divided by 78 will give you 32. Great. So what we're going to do is we're going to form two new equations. Okay, so equations 3 and 4. By multiplying equation 1 by 39, and we get 468x squared minus 156xy plus 429y squared equals 2,496, and 512x squared minus 288xy plus 352y squared equals 2,496. So by subtracting one from the other, I eliminate the constant term. In fact, it sort of negates itself and it all disappears, which is really nice, which is what we want. Okay, so I'm just going to do 3 minus 4. Okay, and subtracting each of the like terms, we get negative 44x squared, so that's 468 minus 512. You get negative 44x squared plus 132xy, so that's negative 156 minus 288xy, okay, or minus negative 288xy, plus 77y squared is equal to 0. Okay, very nice. Now the constant term's out of the way. Now, given that it's now what looks like a quadratic equation, we can divide both sides by 11, which is nice. You can see that everything, all the coefficients here are divisible by 11. Okay, and we end up with negative 4x squared plus 12kx squared plus 7k squared x squared. So that's by letting by letting y equals kx, we end up with negative 4x squared plus 12kx squared plus 7k squared x squared equals 0. Okay, because that's what we're told, sort of in the first part of the question, by letting y equals kx. So anywhere you have y in the equation, just substitute kx in its place and just multiply it through, and you end up with what you end up with here, 12kx squared and 7k squared x squared. Now, if you go back to the original question, or the first line of part A, it says show that 7k squared plus 12k minus 4 equals 0. 7, 12 minus 4, or negative 4. Can we see that here? There's a negative 4, there's a positive 12, and there's a positive 7. So it looks like we got our coefficients. Now, factorize out x squared, because that seems to be one of the common factor there, and you end up with negative 4 plus 12k plus 7k squared equals 0. So I'm just going to rearrange that just to make it look like the quadratic in the first line of part A. X squared outside of 7k squared plus 12k minus 4 equals 0. Now, these two are being multiplied together. So we have x squared multiplied by this whole thing in brackets equals 0. And if there's two factors being multiplied together to give you 0, that means either x squared must equal 0 or 7k squared plus 12k minus 4 must equal 0 in order for the product to equal 0. So therefore, 7k squared plus 12k minus 4 equals 0 as required. Okay, so that's part A. Very nice. Let's go on to part B now. Okay, so I'll just leave part A around, so I might have to refer back to it. So for part B, hence or otherwise, solve the two equations simultaneously. Okay, so these are the two equations again. Okay, so you might want to write these down. 12x squared minus 4xy plus 11y squared equals 64, and 16x squared minus 9xy plus 11y squared equals 78. So we're going to solve this simultaneously now. It says hence or otherwise. Hence means let's use part A, or otherwise means, well, go ahead and try your own methods. I think we can use part A. Now, we know that there's a solution if, given that 7k squared plus 12k minus 4 equals 0, if we can find values for k, then we can substitute that into one of the equations, say equation 1 or equation 2, and then solve for x. And then we can solve for y, sort of consequently. Now, from part A, we know that we proved that 7k squared plus 12k minus 4 equals 0. If we factorize it, and that's sort of easy enough to factorize there. So solving for k, we have in brackets 7k minus 2 multiplied by k plus 2 in brackets equals 0. That's a sort of the factorizing method. Therefore, k equals negative 2 or 217. So there are two valid values for k for this equation. So if we go back to equation number 1, so I'll just put that back there. So there's equation number 1. So you can use either one. We're going to solve this simultaneously, so it doesn't actually matter which equation you use. I'll just conveniently use number 1 because I can. We got 12x squared minus 4xy plus 11y squared equals 64. We're given that y, we'll let y equal kx. Okay, so 12x squared minus 4kx squared plus 11k squared x squared equals 64. Great, I think we've seen this before. Factorize out the x squared, fantastic. So we've got 12 minus 4k plus 11k squared equals 64. Now this is where the x squared comes into it. Think, okay, great. We're not going to let this equal 0. It's not equal to 0. It's equal to 64, which means that they can't be, x squared can't equal 0, nor can this quadratic equal 0. But we have two values for k. We've got k equals negative 2, and we also have k equals 217. So let's try both. Okay, this is where we have the two cases now. Okay, so case k equals negative 2. Let's see what happens. We have x squared times 12 minus 4 times negative 2 plus 11 times negative 2 in brackets all squared is equal to 64. So all I've done is I've substituted k equals negative 2 into this equation here. Okay, equals 64. We end up with x squared times 64 equals 64. How convenient. X equals negative 1 or 1, which makes perfect sense. If you divide both sides by 64, you got x squared equals 1. I might just write that in there somewhere. So, so x squared equals 1. So therefore, x equals negative 1 or 1. Okay, nice, clean solution. Now, given that y equals kx, well, we've sort of been told that, right? Letting y equal kx, and we know that in this case, k equals negative 2. We can then get the values of y that we need. So when x equals negative 1, okay, and k equals negative 2, substituting that into this equation here, y equals 2. And when x equals 1, sort of substituting it into this equation here, y equals negative 2. Makes sense. Negative 2 times 1 equals negative 2. Very nice. Now, what about the case when k equals 217? Same thing. Just repeat the same process. So x squared outside of 12 minus 4 outside of 217 plus 11 outside of 217 all squared equals 64. You can evaluate what's in the outer brackets there. X squared times 576 on 49 equals 64. Basic equation now. X squared equals 64 divided by 576 on 49. We get a nice fraction here. X squared equals 49 on 9. Who would have thought we'd have a fraction where it's a square or a perfect square, and we can just take the square root of that, plus or minus of course, because we're taking the square root of a square. X equals negative 7 on 3 or 7 on 3. So two very nice, well-behaved fractions. Now again, given that y equals kx and k equals 2 on 7, do the substitution again. So when x equals negative 7 on 3, y equals negative 2 on 3, you can try that for yourself. 2 on 7 times negative 7 on 3 is negative 2 on 3. And when x equals 7 on 3, y equals 2 on 3. Again, just basic substitution there. So we can summarize the solution set. Okay, so the solution set, I'll just put the curly braces there. The solution set is, and there's 4 of them, negative 1, 2, 1, 2, negative 7 on 3, negative 2 on 3, and 7 on 3, 2 on 3. So I've just expressed them as coordinate pairs. And that's the solution to that simultaneous equation. Okay. If you want to, and you've got the time, you can of course substitute these two values into the original two equations. I'm not going to do that in this video. You can do that for yourself. Substitute in these values. So for example, negative 1, 2, and check to see that left-hand side equals right-hand side in both cases. Thank you for watching, and all the best for your studies.